In this video, we will see dry run of the code. Now let's do a dry run of this approach too. Okay. So let's see. So let's start with here. I am calling hrop, right? So I will write with hr only. Okay. To simply reducing the space. So hr, I am passing the num. So I won't write nums again and again. And I will write the indexes. So nums dot length minus 1. That means I am passing 4. What is the complete length? It is 5. N minus 1, that is 4. So I am passing hr with the index of 4. Okay, so let me put in the stack that I am passing. I am calling hr4. Okay, now this function is called. Now let's execute this function. Is your I is less than 0? No. Is your I is greater than 0 or equal to 0? No, it's not. Is dp is defined? So let me define dp. Right. So suppose this is my dp here. Right. This dp of I is defined. So no here 0, 1, 2, 3, 4. dp of I is also not defined. Right. So I will say, let's do one thing. Let's do a take call. So I have one take call, that is nums of I. What is nums of I? 1. 1 plus again one function call, right? So again one hr call with an index of value I minus 2. Yani 4 minus 2, it will be 2. Right. So in my call stack, it will be hr of 2. Right. I will first calculate hr of 2. Right. So now let's calculate hr of 2. So hr of 2, let's see. So basically hr4 called hr of 2, and I will execute hr of 2. Right. See, or let me write it somehow. Okay, let be the same. Right. This called hr of. Now what is hr of 2? Is I is less than 0? No. Is I is equals to 0? No. Is dp of I is defined? dp of 2 is defined? No. So let take equals to nums of I. So here again I will take equals to nums of I. What is nums of I? That is 9. 9 plus again one function call, that is hr of nums I minus 2. So I minus 2, 2 minus 2, it will be 0. So I am calling one more function hr0. Alright. Now let's execute this hr0 first. Right. So I will call hr0 here. And hr0 will be, is I is less than 0? No. Is I is equals to 0? Yes. So is I equals to 0? So I will return nums of 0. What is nums of 0? That is 2. So here I will return 2. Alright. So here the value will be 2. Okay. So let's execute. So hr0 is done, right? I will simply remove from the stack. So I will remove it and take God's nums of I, yani 9 plus hr of 0, that is 2. So my take value will become, let me put it here. Now my take value will become 9 plus 2, that is 11. Right. Now not take. What is not take? NT. Right. NT will be 0 plus again hr, more function call. So I will call hr with nums of I minus 1. What is this function? Okay, we are evaluating hr2, right? 2 I minus 1. So hr of 1, right? So let's execute this one. Let me remove this. We are evaluating hr, right? So hr1, right? So I will call hr1. Let me remove this from the call stack and I will evaluate hr1. What will be hr1? Let's see. Right. So I will come here. Is I is less than 0? No. Is I is equals to 0? No. Is dp of I is defined? dp of 0, 1 is defined? No. So I will say let take. So take will be nums of I. What is nums of I? That is 7 plus hr of I minus 2. Again one function call, right? So I will call hr of I minus 2. Yani 1 minus 2. That means minus 1. So I will call hr of minus 1. Now what is hr of minus 1? Is I is less than 0? Yes. So return 0. So can I directly return 0 here? And because I am returning 0, can I say my hr minus 1 is done? Yes. Right. So your take value is 7. Okay. What is your not take value? So take value here is 0 plus again one function called hr of nums of I minus 1. Who called it? 1 called it, right? So 1 minus 1, that means 0. So I will execute hr of 0. Is I is less than 0? No. Is I equals to 0? Yes. Right? So I will execute this and I will get 2 as a return. So can I write that the value of hr0 is 2? Yes. So hr0 is also done. I have not created here, but hr of 0 is also done. Now we got take 7 and not take is 2, right? I will say dp of I will be max of 7 and 2. dp of I means dp of 1. So the max of 7 and 2 will be 7 only. So dp of I will be 7 and I will return dp of I. So basically I will return max. So here I will return 7, right? So this will be now 7, right? Okay. Now let's see here. We are getting max here 9 plus 2 11, not take 7, only 7, right? So dp of I, but that means dp of 2 will be max of 11 and 7, which is max 11. So dp of 2 will be 11, right? And I will return the dp of I. So I will return 11. So can I say here it will be 11? Yes, right? So take value is 1 plus 11. That means the take value is 12. Now I will calculate not take here. What will be not take? That is 0 plus hr of I minus 1. So again one function called hr, and because this hr1 and hr2 is done, can I say I will remove from the stack? Yes, done. Now again one function called I minus 1. 2 is there, 2 minus 1 will be 1, hr of 1. So I will execute this one. I will check is I is less than 0? No. Is I is equals to 0? No. Is dp of I is defined? hr of 1 is defined? Yes, it is defined. 7. So return dp of I. So I will return 7 here, right? So for hr of 4, I have a take value of 11 plus 1, that is 12, right? And a not take value here, that is 7. So which is maximum? Which is maximum? dp of I is equals to met dot max of take and not take. That is maximum is 12. So what I will do? I will simply return here just a Here it won't be hr of 1, I guess. Although my answer will be correct, but it not be hr of 1. I missed it. Basically hr of 4 called, this function called, right? So 4 minus 1, right? 4 minus 1 will be hr of 3. So it will be hr of 3. So I will calculate hr of 3 first, right? And I will check is hr of 3 is defined in dp? No, it's not defined. So again I will do a take and not take call, right? So my take will be nums of I, that means 3, plus again one function call, that is hr of I minus 1. So I will call hr of, which is 3. 3 minus 1, that is I will call hr of 2. So now let's execute hr of 2. We have an call of hr of 2. So is I is less than 0? No. Is I is equals to 0? No. Is dp of I is defined? dp of 2 is defined? Yes. That is 11. So I will simply put 11 and hr of 2 will be removed because the function is dead. Function is completed. Now not take will be 0 plus 3 minus 1. That means again hr of 2. Right? Why it should be same? It should be 3 minus 1. I guess hr of 1, not, sorry, sir. It should not be hr of 2. 3 minus 2, I minus 2. So it will be 1, hr of 1. What is hr of 1? 7. So instead of 11 here, I will mention 7 here, right? And here 3 minus 1, I will call 2, hr of 2. What will be hr of 2? That is 11. So I will mention 11 here, right? Okay. So takes is 10, not take is 11. dp of I will be maximum take and not take. What is maximum? 11. So I will mention dp of I hr of 3, 11, and I will return it. So I will return here. I will return here that hr of 3 is 11. Now take is 12 here, not take is 11. So dp of I will be max of take and not take. That means 12, right? So dp of I will be 12 and I will return dp of I. So basically I will return 12 here, right? So the final value will be 12, right? And this function will be completed, right? HR3 is done, HR4 is done, and the final value is 12, and the answer is also 12. So remember how you are calculating? You are calculating for this place, right? And how you are calculating? You are going to this place, you are checking, and you are checking with this one, right? Can be this be a maximum? You are going here, and you have already defined that if dp of 0 is there, we will return 2. So that's why we have not used this one. But basically, this is how we are using it. Remember? So this will be a dry run of this one. Now let's check for approach 3 that we have discussed. So let me again quickly copy this one, paste it here, and copy the DP, paste it here, right? And now see. So this is my DP. That's a 0, 1, 2, 3, 4, right? And so let's see here. Okay, I have defined a DP. DP of 0 will be nums of 0. So I will define with 2, right? Let me change the color. I will define with the 2. Then I will start from 1. So here my pointer will start, and I will take one value. Take will be nums of I. So let's define a take will be nums of I for 1. That is 7. Is I is greater than 1? No, is equals to 1. Then not take will be 0 of dp I minus 1. So 1 minus 1 will be dp of 0. That is 2. So it will be 2. And dp of I will be maximum of take and not take. 7 and 2 maximum 7. So dp of I will be 7, right? And I plus 1 will come to here, right? Now again my take will be nums of I. So my take will be 9. Is I is greater than 1? Yes. So plus dp of I minus 2. What is I minus 2? I is 2. 2 minus 2. That will be 0. That means 2. So 9 plus 2. That is 11. Not take will be 0 plus dp of I minus 1. I is 2. 2 minus 1 will be 1. So 0 plus 7 will be 7. dp of I will be maximum of these two. So that means 11. And return, I am not returning it here. So I plus 1. I will be here. 8. I is 3. Again, take value will be nums of I. So nums of I, that is 3 greater than 1. So dp plus I minus 2. Take plus I minus 2. So 3 minus 2, that means 1. D plus 7, it will be 10. Right? Not take value will be 0 plus dp of I minus 1. 3 minus 1, that means 2. So 11. Right? Which is maximum? 10 and 11. 11. So dp of I will be 11. Right? Again, let's move further. I will be here. Right? So you will calculate again. Take will be 1. 1 plus dp of I minus 2. 4 minus 2. That means 11. Right? dp. So take will be 12. Not take will be 0 plus dp of I minus 1. So dp of I minus 1, that means that is 11. Right? So which is maximum? 12 and 11. 12. Right? So I will mention 12. And I plus I is done now. I will return the last element of my dp, and that is 12. Okay, that is your answer. And basically this is how we are using it. Okay, approach 3. Now let's quickly discuss approach 4. Okay, so let me copy the same. Right, and now we don't use dp. So 0, 1, 2, 3, 4, and we have this array. So what I will do here, see, now we have not dp, right? So let me remove this one. We don't have dp. Last one, we have last one, right? We have last two, last one, and last two. Last one is nums of 0, that means 2. Last 2 is 0. Okay, so again I will start from I equals to 1. Okay, my take, what will be my take? Take will be nums of I. Nums of I, that means 7. Right? And is I is greater than 1? No. So not take will be 0 plus last one. So not take will be 0 plus last one, that is 2. Right? So what I will do, I will simply say last two will be last one. So now last two will equals to 2, right? This one. And last one will be max of take and not take. What is max? That is 7. So my last one will be 7. Okay. So far so good. Basically, if you check according to your DP, so you are at here, right? You are at here 7. You are getting the last one value 7. Okay. Again, let's move. I will be here. I will be now at 2, right? Take will be nums of I. So take will be nums of I. That means 9, right? Is I is greater than 1? Yes. Now it's greater than 1. Take plus equals to last 2. What is last 2? That is 2. So 9 plus 2, that will be 11, right? So can I simply say take will become 11? Not take will become 0 plus last one. What is 0 plus last one? That is 7. Last one is 7. So not take will become 7, right? Now last two will become last one. So last two will update to last one 7, and your last one will be updated to max of take and not take. 11 and 7, right? Which is maximum? 11. So last one will become 11. You can see now you are getting these two values only, 7 and 11. Again, you will move further, right? I will be here, right? Take will be nums of I. So take will be 3, right? Is I greater than 1? Yes. So take plus equals to last 2. What is last 2? That is 7, right? You are taking last 2. That is 7. That is 10, right? And not take will be last one. So not take will be 11. Now last two will become again last one. So last two will become 11. And last one will be max of these two. 11, 10, which is maximum? 11. So last again 11. So you can see again we have last one as an 11. Now again I equals to here, right? Take will be nums of I. So nums of I, that means 1. So let me mention take will be 1. If I is greater than 0 plus last 2, what is last 2? It is 11. So 1 plus 11, 12. Not take will be 0 plus last one. So 0 plus last one, what is last one? 11. So it will be 11. Now last 2 will become last one. Last 2 will become last one, 11. And last one will be max of these, right? So 12 and 11, which is maximum? 12, right? And that's done. Indeed, we will move ahead. That's end of for loop. You will return last one. You will return 12. 12 is your answer according to your DP's last value. So you are getting that we are using these two values only. We are using these two values only, right? So in all the three approaches, let's quickly discuss the time and space complexity. For time complexity here, we go of n, checking all nodes because of DP. Space complexity will be we go of 2n, right? One space and one in for recursion is and one for DP, right? Which is nearly equals to big O of n. Here, time complexity will be big O of n, right? For loop, space complexity will be big O of n because of DP, right? Here, time complexity will be big O of n, right? And space complexity will be big O of 1 because taking these two variables only constant. So yeah, this will be overall time and space complexity, and this was all about all the approaches. I hope you got a complete clear understanding of house robber problem. Okay. The next video, we'll more talk about house robber variation. Okay. So in the next video, I will take the house robber variation. Till then, bye bye.